Now we'll see the second essential part of electrical machine, that is rotor. In rotating machines we used to have two essential parts. In up to previous slide we have discussed about the first essential part, that is stator, in which we are having stator frame, stator core and stator winding. And now in the second essential part is rotating part, that is rotor. In three-phase induction motor we are having two types of rotor. So based on those types we are having two forms of induction motor available in markets. The very first one is squirrel cage induction motor and second one is wound rotor or slippering type of induction motor. Now we'll move with the squirrel cage induction motor. Usually in rotating electrical machines, stator and rotor used to have its own core, and the purpose of having core is the main function is to carry flux if it is of field winding, or else it is going to carry only the windings. So for carrying those windings it is used to have slots on its periphery, and if it is stator core usually we used to have slots on its inner periphery, whereas if it is of rotor core we used to have slots on its outer periphery. The purpose of having inner peripheral slots and the outer peripheral slots is to bring those windings nearer to the air gap. So the energy conversion used to happen in the air gap. So in order to achieve those energy conversions in the air gap, we preferring inner periphery to place windings on the stator and outer periphery on the rotor core to place windings on the rotor. So both stator and rotor used to have slots, and the core will be of laminated cylindrical shaped core. And the reason for going with laminated type and silicon steel is to reduce eddy current loss and hysteresis losses respectively. So here in this kind of rotor too, we are going to have a rotor core, and the shape should be of cylindrical type, of course, because rotor is being placed on the shaft. It is the inner part of the electrical rotating machine. It is of a cylindrical in shape. It should be of cylindrical in shape. So and it is going to have slots on its periphery. So we used to prefer outer periphery for placing slots, and the purpose of having slot is to place windings. If it is a field winding, the purpose may be of to carry flux, but here already we are having a field winding on the stator. So here the rotor winding is not going to carry any flux. I mean, it is not going to create any flux initially. And now the slots will be of any open type, closed or semi-closed type, but here the small change in the slot arrangement in three-phase induction motor, especially in squirrel cage type, is to be noted, because in other machines we used to have slots only to carry windings, but here we are not going to use any windings on the rotor. Instead we are going to use conductor bars. So we used to call those as a rotor conductors. So the conductors means we used to prefer conducting material. So we can go with copper or aluminium or even brass. So for arranging those rotor conductors we prefer slot. It means we are going to embed all such rotor conductors on this slot. And one more thing, here in all the machines we used to have a symmetrical arrangement of slots. It means all the slots will be parallel to each other. But whereas in this squirrel cage type of machine we are not going to have any parallel arrangement of slots. Instead we are going to do some changes in its symmetry. It means we are going to change its position. So yeah, a little bit. So it is, we can call that changes or distortion in the position as skewing. The purpose of skewing a slot on the squirrel cage induction rotor is to prevent magnetic locking of stator teeth and rotor teeth. The statement indicates that if there is no magnetic locking, means it indicates that we are having a self-starting of three-phase induction motor. But whereas in synchronous motor and the single phase induction motor, it is not so. It is those motors are not self-starting motor. But in three-phase induction motor, it is a self-starting, and it is one of the main reason for making our induction motor, three-phase induction motor, as self-starting. It means we are preventing the magnetic locking between stator and rotor too, and it can be achieved only by making a skewing arrangement of slots on the rotor core. So this is the purpose of having skewing arrangement of slots on the rotor. And one more reason for skewing is it will reduce the humming noises on the rotor while moving. So second advantages of making skewing slot is it will reduce humming noise. The first is it will reduce magnetic locking. And in that such skewed slots, we are going to embed the rotor conductors of material aluminium, copper or brass. And by manufacturing itself, we are going to short all the rotor conductors at the ends. So we are going to bring all the rotor conductors, and we are going to connect all the rotor conductors together at the end of on both sides of the rotor. And for making such a short circuit arrangement of all the rotor conductors, we are going to use one metal ring, that is a conducting type of ring. So for that conduction, we are going to prefer copper or aluminium. So that metal ring on both ends of the rotor core, we used to call this as a end ring, and it is used to for connecting all the rotor conductors together. So it is going to look like an entire complete short circuit by structure itself. At the time of manufacturing itself, we are creating a short circuited arrangement of rotor conductors on the squirrel cage rotor. And now what we are going to do is, the thing is here, since we are having all short circuit arrangement by structure, in the resistance of the rotor will be very small, because by structure itself it is a short circuit, so we can expect more current, and if the current is more, the resistance obviously will be very less. So we cannot add any external resistance to its rotor circuit. So it's one of the another drawback in this squirrel cage induction motor. So it means that we cannot by means of adding resistance, we cannot do any such speed control, or we cannot increase any starting torque. So we cannot expect any high starting torque in this kind of squirrel cage induction motor. So this kind of squirrel cage induction motors will be applicable only to the medium starting torque of applications. So since it is a short circuited in nature, the resistance is very small. So that's the reason for choosing this kind of motor only to the medium starting torque. Now we'll see the picture of those structures of squirrel cage induction motor. And for making such arrangement, the last arrangement of squirrel cage, we required slicings, that is stampings of iron part, that is steel, silicon steel, and it is of laminated type, and we know the thicknesses of those types, and it is after compiling or stamping together, we will get this kind of rotor core, and in which we are having slots on its outer periphery. Here we can see that skewing arrangement of slots, and we are going to embed the rotor conductors. So here we are having that brown color is having a rotor conductor, and at the end of those rotor core, we are having a ring form of a conducting material, and we used to call that as a end ring. So because of that end ring, we are not having a high starting torque in this kind of motor. And one more reason for using such end ring is, at the time of rotation, since we are not using any winding, we are placing only the rotor bars. At the time of rotation, it will move off from these slots. So in order to avoid such things, we are making a short circuit arrangement at the time of manufacturing the motor itself. And after doing such things, we are going to place this rotor arrangement inside the rotor frame, and in stator frame. So in stator frame, next to stator frame, inside the stator frame, we are having stator core, and in which we are placing the stator winding. We are calling that as a field winding. And after that, we have to maintain air gap, and the air gap should be very small, and then we are going to place the rotor arrangement. And now we'll see the advantages and applications of the squirrel cage induction motor. And before that, we'll see the name, why we are calling this type of induction motor as a squirrel cage induction motor. So if we are going to look at only the rotor conductor arrangement in the rotor by removing imagining only the rotor conductors, we are not bothering about the rotor core, we are just concentrating only on the rotor conductors and its arrangement, and it is completely looking like a cage of a squirrel. So that we are calling this kind of induction motor as a squirrel cage induction motor. Now we'll move on to the advantages and the applications of squirrel cage induction motor. So as we have seen the structure, it is looking like very easy. So the construction will be very easy, and also it's very rugged. So the maintenance will be very easy because by it is having a short circuit arrangement of rotor conductors, so we cannot add any external resistance to the rotor conductors. So if you want to add anything externally into a machine, we have to go with the connection, that is a bridge between the rotor and the external circuitry. But here we cannot add any external part into a rotor conductor, and if we are going for any inclusion of external part into a rotor, we have to make a bridge by means of using brushes and its assembly. But here we are not having any such arrangement, so we are not going for brush assembly as well as another supplementary things. So we can go with less maintenance for this kind of squirrel cage induction motor. And because of these advantages, and we can use this kind of motors for this list of applications. The first thing is lathe and drilling machine, and even in blowers of printer machine we are using such kind of squirrel cage induction motor. The reason is all such applications require medium starting torque. Now we will move on to the second type of rotor, that is wound rotor. Sometimes we used to call that as a slip-ring induction motor because it is having a slip-ring assembly on its shaft. So all the rotor, it is somewhat similar to the rotor of other machines. It used to have a rotor core. It should be of a laminated type, and it is going to have a stamped together, and the material will be of silicon steel, and it is going to have a lamination and all things, and it is going to have a slot. And the main thing we have to concentrate here is we have to take the number of slots on its rotor core should be same as the count of slots on the stator. So this is an important thing we have to keep in mind while designing slip-ring induction motor. The number of rotor poles should be equal to the number of stator poles, and the windings will be, the number of turns per winding will be very less. For each phase we used to have a winding, and these windings will have very fewer turns per phase, and it is going to have only a lesser number of slots, and in the slot we are going to have a winding. But whereas in squirrel cage we had conductors, but here we are not going to have such type of conductors. Instead we are going to have a winding. So in order to place winding, we have to go with either star or delta connection. And here in wound rotor we are going to prefer star type of connection because we are going to add an external resistance to the rotor conductor. So in order to make such external circuitry into a rotor circuitry, we are going to arrange such type of windings on the slot by means of a star connection. So, and the terminals of the star connection, one end of the star connection will be connected to the slip ring assembly, which is also available on the same shaft. Usually we used to have a rotor core on a shaft, and next to the rotor core we used to have a slip ring assembly, and this slip ring will be connected to the terminals of the star connected rotor winding. And these slip rings will be having a brush assembly on the top of it, and it is going to be mounted with the stator frame. And usually the material preferred for brush is carbon, and whereas for slip ring it is also a type of conductor, so we are going to use copper ring as a slip rings. So since if we are dealing with three-phase induction motor, we required 3 slip rings. And another end of the slip ring will be connected to brushes, and that brush will be connected to external resistance, and that resistance is required for controlling the speed. If we are going with any speed control operation, we can make use of this kind of machine, or if we prefer any high starting torque, we can go with this kind of machine. Whereas in squirrel cage, we cannot expect higher starting torque. It is only for the application where we require medium starting torque, but here we can get high starting torque. So for improving such high torque in this 3-phase induction motor, we are using external resistance. Unless if we are not using any external resistance, we cannot obtain such highest starting torque. So the reason is for controlling the speed as well as for improving the starting torque, we are using such kind of external resistance. With the help of slip ring and brush assembly, we are going to add external resistance to the rotor circuitry. And now we'll see the structure of slip ring induction motor. And here in rotor, we are having a star connection, and the one end of this terminal 3-phase rotor terminals are being connected to slip ring. The other end of slip ring is having brushes, and the brush is going to connect with external resistance. So rotor terminals are being connected with one end of slip ring, and other end is having brush assembly, and this brush assembly is going to connect with external resistance, and the external resistance should be of star connected, because here we are having a star connection, and here also we prefer a star connected external resistance. And usually the external resistance are required at the time of starting, because our purpose is to increase the starting torque. So for increasing such starting torque, we require external resistance. So only at the time of starting, we are going to have a external resistance in the rotor circuit. And after, at the time of gradually, if we are going to improve the operation, and if we are going to increase the speed, gradually we have to cut down the external resistance being connected to the rotor circuit. And at the time of running, initially we require slip ring. So at the time of running, we are not going to disconnect the slip ring by stopping the supply to the stator, or we are going to cut the operation. I mean, we are not going to cut the supply to the entire machine. So at the time of running itself, we have to cut down the slip ring from the rotor circuitry. It means we have to cut down the resistance from the rotor circuit. So in order to do such disconnection of slip ring at the time of running, we are going to connect all the 3 slip rings to a metal collar. It is going to connect all the slip rings together, and also the brushes will be removed from the entire circuitry. It will happen only at the time of running. It means by slowly increasing the speed, after increasing the speed up to 75% of its rated speed, we can do such things. It means we can remove the slip rings and brush assembly from the rotor windings. Now we'll see the structure of slip ring induction motor, and here too we are having a laminated type of rotor core, and it is having a winding arrangement. And here we used to have a star connected rotor windings, and at the other end of the rotor core on the shaft we used to have slip rings. Here we are having 3 windings, so we are using 3 slip rings. So we have to make some insulation between the steel shaft and the slip ring. By using backlight, we can insulate that metal slip ring and the steel shaft. And after arranging the rotor conductors in a star connection, we can insert such rotor along with the shaft inside the stator construction. So inside the stator frame, we used to have a stator core with the stator field winding, and inside by maintaining a small air gap, we are going to house all such rotor assembly into the stator frame. And on the top of the slip ring, we can see the brush assembly, and this is having the holdings on the stator frame. And usually the black color is nothing but the brush. It is of a carbon material. Because of these other brushes, we used to have a star connected external rheostat, and it will be available only at the time of starting to increase the highest starting torque. And at the time of after reaching 75% of its rated speed, we can cut down this external resistance by connecting all the slip rings together by using a metallic collar. And at the time, brushes also will get removed from the rotor circuitry. Now we'll see the advantages of slip ring induction motor. Since it is having a high starting torque, and it will be having a low starting current, because we are adding a external rheostat at the time of starting. If the resistance is very high, at the time we used to have a low current. So it is having a low starting current and high starting torque. And we can add external resistance to the rotor circuitry. So because of that, we can able to control the speed of the induction motor. So we will see based on that advantages, we are having this kind of applications. So this is the application area for this kind of slip ring induction motor. Say for example, in hoist, crane and elevator, we required high starting torque. So on such applications, we can prefer slip ring induction motor. But whereas school cage induction motor will be applicable only where we require medium starting torque, but it is at the place where we require high starting torque. So that's all about the constructional details of three-phase induction motor. So in three-phase induction motor, we are having a stator in which we are having three parts on the stator. One is stator frame, stator core, and then stator field winding. And next to that, we are having a rotor. In a three-phase induction motor, we are having two types of rotor. One is squirrel cage type and another one is slip ring type. In squirrel cage, we used to have a rotor conductors instead of having rotor winding, and the slot should be of spring type to avoid magnetic locking. And here in slip ring also, we are having the same rotor structure. Instead, in slots, instead of having rotor conductors, here we are having rotor windings that should be of star connected. But the rotor skewing is also available in this kind of slip ring. Also, we used to have a skewing kind of slots, but instead of rotor conductors, here we are having rotor windings in star connection, and the terminals of those star connection will be connected to the one end of slip ring, and other end of slip ring will be connected to the brushes assembly, and the brushes will be connected also with external rheostat. The rheostat should be of star connection, and the rheostat will be connected to the rotor circuitry only at the time of starting in order to enhance the high starting torque. Also, to reduce the starting current, we are having this external rheostat, and after reaching up to 75% of its rated speed, we can cut down the external rheostat completely from the rotor circuit by connecting all the slip rings together by using a metallic collar. At the time, brushes also will get removed from the rotor circuitry. That's all about the constructional details of three-phase induction motor. In next video, we'll discuss about the working principle of three-phase induction motor. Thank you.